Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Digital Image and Video Processing. So friends, in the last video, we discussed regarding the wavelet. What is a wavelet? Continuous wavelet transform. In this video, we are going to discuss few more things regarding the wavelet. It is image pyramid, building the image pyramids and the subband filter bank, wavelet bank. So we are going to discuss very first regarding the image pyramid. Now what this image pyramid represents? So the image pyramid, that's a kind of the structure which is used to represent the images at more than one resolution. So multi-resolution structure you can see. So total number of elements present in a p plus 1 level pyramid for p greater than 0, that is p is the picture element. So it is n square in bracket 1 plus 1 upon 4 raised to 1 plus 1 upon 4 raised to 2 plus dash 1 upon 4 raised to p less than or equal to 4 by 3 n square. So this is the equation that is required for all the image element. So now this is the structure of the various resolution, and it is known as the image pyramid. So here the structure that consists of the 1 by 1, 2 by 2, 4 by 4 element, n by 2 element and n by n element. The final level, okay, that is level J, and it starts from the level 0 to level 1, level 2, level J minus 1 to level J. So each image element that are having the different resolution. So the collection of decreasing resolution images, they are arranged in a shape of the pyramid. So decreasing resolution images, they are arranged in the particular the shape. So that we can see from the pyramid diagram. So highest resolution image, that is always at the pyramid base. And now as you move up the pyramid, both the size and the resolution value that decreases. The base level of the size, that is the 2 raised to j to 2 raised to j. So the general level j of size 2 raised to j by 2 raised to j, where 0 is less than or equal to small j is less than or equal to the capital J. So now the pyramid, they may get the truncated at the value p, and p value that is between 1 and j. So number of the pixels in a pyramid, that is with the p plus 1 level, that we can define by using this particular equations. So now how to build the image pyramid? So now here we can see the structure. In that you can see that the level j input image. So input image elements, okay, they are the input. Now approximation filter. Now this approximation filter will find out the approximate value of the pixels. Now to display this particular value for improving the resolution, here the downsampler, okay, that can be used, okay. So it is the factor that is the down by factor 2. Now that value will come as the level j minus 1 approximation. Now the same value that is at the level j value, okay. Now what happened, that the same value that is a upsampler by the factor 2, and it is given to the interpolation filter, and this interpolation filter will give the predicted output. So one output we will get, that is the approximate value of the pixel, and another one that is the prediction value, okay, of the image pyramid. So level j minus 1, that gives the approximation output which provides the image needed to build an approximation pyramid. Okay, so one is given the approximation pyramid value. Now the next one that was the last in the earlier the diagram, it was the level J prediction residual output, which is used to build a complementary prediction residual pyramid value. So now this way we have the predicted and the approximated output value of the image pixels would be there. So all other levels contain the prediction residuals, while the level J prediction residual is the difference between the particular level. So J approximation and an estimate of the level J minus 1 approximation, that is based on the J minus 1 approximation. So this way it contains only reduced resolution approximation of the input image at the top level. So both the approximation and the prediction residual pyramids are computed in an iterative fashion, and this way we can make the pyramid. So now start by placing the original image in the level J of the approximation pyramid. So now here mainly the three steps we need to perform while the image pyramid that is formed, which is the step number 1. The step number 1, that is compute a reduced resolution approximation of level J input image. Then it is done by what? Filtering and the downsampling. And the filtered result that by the factor 2. Now place this result approximation at the level J minus 1 of the approximation pyramid. So this is the step number 1. This is the upper part of the block diagram which shows the earlier. Now the second step. The second step is create an estimate of the level J input image from the reduced resolution approximation generated in the step number 1. It done by the upsampling and filtering the generated approximation, resulting the prediction image will have the same dimensions as the level J input image. So now this is the middle part, and the final step, that is a step number 3. In that we need to compute the difference between the prediction image of the step number 2 and input to the step number 1. So the result in the level J of the prediction residual pyramid that we will get. So now after performing the P iterations, the level J minus P approximation output, which is placed in the prediction residual pyramid at the level the J minus P. So the variety of the approximation and the interpolation filters that can be used: neighborhood averaging producing the mean pyramid, okay, low pass Gaussian filtering producing the Gaussian pyramid, no filtering producing the subsampling pyramids, interpolation filter that can be based on the nearest neighbor, bilinear and bicubic. So this way we can do this. Now in that, what was the upsampling? So it doubles the spatial dimension of the approximation image. Given an integer n and a 1D sequence of the sample fn, upsampled sequence which is given by the following equation, that is a factor by 2 we are doing the upsampling. So it is like a doubler. So it is equal to f of n by 2 when the n is the even. And for other values, this f2 value, that is the 0. So insert a 0 after every sample in the sequence. Now the downsampling. What is the downsampling? As we know that while you want to predict the output, so you want to match the two dimension, it should be both the same. So earlier if it is the downsample by the 2, upsample by the 2, then need the downsampling by the factor 2. So it halves the spatial dimensions of the prediction image, and which is given by f2 downsampling of n equal to f of 2n. So discard every other sample in this case. So this is regarding the image pyramid. Next is the subband filter bank. Subband. What is a subband? A set of band limited component as a result of decomposing an image. Decomposition that is formed such that the subbands can be reassembled to reconstruct the original image without the error. So here we are dividing the image into the number of bands. So set of the band limited component, and as a result of the decomposing the particular image. This is the diagram of the subband filter bank. So here the xn, that is the input sequence or the input image, and output, the x cap of n, that is the output image. So now here the two particular the part is there in the subband filtering. First is h0n, downsampling, by 2, upsampling, okay, and the output sequence, that is opting. Similarly h1 of n, here the 2 band is shown, same way the 4 band, okay, the sampling filter bank is there. So this is the 2 band filter bank for a one-dimensional subcoding and the decoding. Now here how can we decompose, okay, the low band and the high band, that is shown in the form of the spectrum splitting properties. So now it is built from 3 basic components. Okay, so what are that? They are the unit delay, multipliers and the adders. These 3 blocks can be used to make the subband filter bank. So unit delays, they are connected in the series. That is to create k-1 delayed version of the input sequence, as we have seen in the diagram. So now the delayed sequence f of n minus 2 can be given by the equation f of n minus 2 equal to f0 where n is equal to 2. Fine. It is f1 when it is 2 plus 1. Similarly, we can have all other values using the equation. So now the delayed sequence, which is also given by this particular equation. So input sequence f of n is equal to f of n minus 0. K minus 1 delayed sequence at the output of the unit delays, as we have seen in the diagram. So delayed sequence which multiplied by the constant h0, h1, h of k minus 1. These are known as the filter coefficients and sum to produce the filter sequence. So f of n is equal to sigma k equal to minus infinity to infinity h of k f of n minus k. We can also write it like this, fn, okay, convolve with the h of n. So each coefficient defines a filter type or filter is order of k. Now, if the input to the filter of a figure A is the unit discrete impulse of the figure B, then we have the fn is equal to sigma k equal to minus infinity to infinity h of k delta n minus k equal to h of n. So substituting the delta n value for the fn value, so it makes the use of the shifting property of the unit discrete impulse, and impulse response of the filter is the kth element sequence of the filter coefficient. So unit impulse which is shifted from the left to right across the top of the filters of the delays. So there are the k coefficients, impulse response is of length k, and filter which is known as the finite impulse response filter. So this is regarding the image pyramid, subband coding, the wavelet filter bank. So thank you very much everyone. Keep watching LGIET Electronics and Communication for more updates related to the digital image and video processing. Thank you very much everyone.